Hello, my name is Daniel. I was a student and a teaching assistant, previous versions of the Neuromatch Academy courses. I'm a PhD student in a Spanish university, even though I'm living in Chile, I'm Venezuelan, and we're gonna talk about polynomial regression today. So polynomial regression is a form of linear regression that we use when we think that the relationship from the inputs to the output variable, our system or the data we're trying to model, is not linear. But we think we can model it through with a polynomial, right? It has the advantage of still being a form of linear regression. So we can use the same methods to estimate the parameters from the data. It is still a form of linear regression because the relationship from the parameters of the model that we estimate from the data to the output of the model is still linear, even though the relationship from the input variables to the output is not going to be linear. Right? Okay, so the first thing we have to do is to build the design matrix, which in the original linear regression or multilinear regression was composed of each input variable. So each column was one input variable, right? Now each column is going to be one input variable raised to each power of the polynomial we're going to try, up to the order of the polynomial we're going to try, which is one of the parameters of this function here. The other parameter is x with the input variables. So since already done here, this is for technical reasons. This is for adding a column of ones so that you want to have a constant term, intercept, one for the whole matrix. And here's the part that we have to do. This ellipsis here doesn't anything. This is what we have to fill. So what we are gonna do is we're gonna take the same matrix, which we already initialized with a column of ones. We're gonna modify it by raising each input variable to each degree of the polynomial. So we're gonna do the same matrix. We're gonna use this function hstack to concatenate each matrix formed from the original variables raised each degree to the original design matrix. So with hstack, what we're gonna do is raise x with the input variables to each one of the degrees we're looking through. 1, 2, order of the. So to raise x to degree, we don't use this operator. This is a mistake here. We use double asterisk, right? And another thing we have to do is surround this in another set of parentheses because this function takes a tuple as its input, right? Where the first member of the tuple is the original matrix to which we are concatenating another matrix horizontally. So this is it.